Hey everyone, we're just continuing our discussion of parametric equations. We've been through a couple examples of giving equations, graphing them, and finding a rectangular equivalent with eliminating the parameter. This time we're going to go the other direction. Given a description of the graph or graph itself, find the equations that match with that graph. And these are not going to be unique answers. As we talked about in our first video on this topic, there's lots of parametric equations that can go through the same path, but we're just looking for one of them. And so it's not always clear exactly like which equations they're looking for. Sometimes there could be lots of them. Sometimes there maybe some restrictions on which path you want to take. So we'll investigate that with these guys. So this one, we have a parametric equation described. There's a line with a slope -2 passing through the point -5, -3, and we just want to find the equation for that line. So I'm going to go ahead and do a quick sketch here. Make my pen. So we're going through -5, -3. So I want to be 2, 3. So there's -5. And -3 is going to be right down here. So there is where I'm looking at. And we want a slope of -2. So slope of -2 means if I go over, let's go ahead and write it up here. So we'll say m is -2, which means that could be, you can think of it one of two ways, -2 over 1 or 2 over -1, right? And it's your rise over run. So down 2 over 1 or up 2 and then left 1. So either way, since I'm already kind of over here on the left side of my graph, I'm going to go down 2 over 1. So down 2 and then over 1. So I'd put a point here. We could go down 2 more, right? Go over 1 right here. But this is going to be the line that we're going through, right through there. And this is my point, right, at -5, -3 that they said I have to go through. So there's a couple ways to do this, but one of the easiest ways is to just start with your x and y at the point that they said you should go through. So I'm going to say x is -5, right, and the y is -3. I know I want to go through that point, so I can just kind of start with x and y with that point, since this is a line. And then the speed at which I trace out that line could vary, but sometimes it just is easiest to go with, say, your slope as your t, right? T is 1, moves one of those slope distances. T is 2, goes another slope distance, and kind of go that way. So if I think of this as being, right, t is 1 when I count my slope, t is 2 over here, t is 0 up here. I'm going to go down 2, right, to the right one. So that means I'm going to -2 and +1 of -2 for my y, +1 for my x. And then if I want to keep going, I'll do it again and again and again for as many times as I want to do it. So this is really -1t and -2t. So for every time unit that I'm going to move, I'm going to add 1 to the x. I'm going to -2 from the y, because that kind of matches with that slope right there of -2. And that's it. That's basically it for that one. So like I said, there are other ways, right? If you want to go through that line twice as fast, I could say +2t and -4t, right? That would keep my slope the same, but just move through that line twice as fast. There's going to be several different answers that you could put. We're just looking for one of them, so that's it. The second one here, we'll go and tackle that one next. So I'm going to go ahead and gonna grab this next one. Find a parametric equation for a circle with radius 5, starting at -1, 0, and moving clockwise. So these are always good to draw out, right? You can't ever go wrong drawing these out unless you just mess up the drawing. So you just want to be very careful. Radius 5, right? That means we're going to start at 5. And I can already see a mistake on this one. This should be a -5, not -10. Because if we're having a radius 5, we shouldn't be at -1. All right, so I'm going to go ahead and modify that a little bit. So that is a -5. So we're going to start at -5, over here. And it's a circle, right? And that circle is going to go clockwise. So clockwise means I'm going to go around my circle, right, kind of this way, clockwise. So that's my movement around the circle. And it should be 5 units, right, kind of every direction. So -5 down here, 5 over here, 5 up here. So it's always 5 units away, right, on that circle. The key with these is that circles are always traced with x being sine or cosine, y being sine or cosine. You'll kind of mix and match which one is which depending on where you start and which direction you're going in for the circle. So I'm going to go ahead and make kind of an x drawing. This is something that we'll do on some future questions as well. So some x in terms of t and some y in terms of t. And actually, let me do it this way first. So I'm going to put my t-axis. All right, so this is my t-axis. And we'll go and put this as my x. So rather than that being a y, that'll be an x. And we're going to trace around this circle. All right, so right now I'm starting at x is -5 right there. So this is going to be the x value down here, -5. So let's see, this is going to be 1, 2, 3, 4, 5, -5 right there. And as we chase around that circle, right, we're going to go clockwise. So the x is going to increase, right, up to 0. It'll keep increasing till we get up to 5. All right, so I'm going to go ahead and kind of modify that. Oh, let's go ahead and grab the pen. So this is going to go up this way until we get to 0 and then 5. All right, so we'll peak out at 5. And then we'll go ahead and come back down the bottom half of the circle, right, going to x is 0 again right there. And then x is -5. So we'll go ahead and switch back, going to x is 0. So from here to 0 down to -5. So then the question is, what function is that looking like? And it'll keep going around, right, that circle as you keep going. Right, so 1 period around, right? So we don't really know how much time that takes. It didn't really tell us a certain amount of time to get around, so we get a pick on that. But this looks like, to me, a negative cosine function, right? I'm starting at a valley, then going up and coming back down. So this would be x is a -5, right, cosine of t. We'll say we're just going to make one full cycle from 0 to 2 pi, right? If they had said something else, like I want it to complete a revolution in a certain amount of time, then you might put some other number in front of the t to match the period. But they didn't tell us the period, so we can just use standard 2 pi units to make that one cycle. All right, what we'll do next, so that is our x. What we'll do next is we'll focus on the y, and kind of the same deal here. Let me go and make some room for my y. I'm going to erase some of this right here. And let's do this one in blue for the pen. And for the highlighter, let's go and use a pink. All right. So with this one, the y, right, again, we have to kind of start in the same place we did before, which is right here. And we're going to go clockwise around the circle, right? And then I'm just going to trace out what happens with that graph. All right, so we're going to start right here at y is 0. And this will be my t-axis, this will be my y-axis. All right, so as we move around, right, same path, so we're basically just tracing this out again. As we move around, we're gonna go and let's see, oh, this is, let me change this and then change that color. I think that'll do what I want. So we're going to go around this way. All right. Again, the y is going to start at 0, go up to 5. All right. So I get to, my y is 5 right there. Come back down to 0. So I'll go ahead and make that on our graph. Right. It goes up to 5, comes back down to 0. And then we'll keep going around the circle. All right. So I'll keep going around the circle. And this time we'll go down to -5 and then back up to 0 to get back to where we started. So go down to -5 at the bottom of the circle and then back up to 0 again by the time we get to that left side. So I'm starting at 0, up to 5, right? Back to 0, down to -5, back to 0 again. All right, so that's kind of my movement as I go around. And then I ask myself, right, there's my movement. It keeps going, right, around and around that circle or the other way. What equation matches with that? Again, we're using the same time frame as the other one. So this would complete one cycle, 2 pi units. And this to me looks like a sine function, right? Just a regular old sine function with a amplitude change of 5. So this would be my y of t, right, is 5 times that sine of t. And that's it. So I got x is -5 cosine t, y is +5 sine t. And then that's basically it. So if you want to put them together, right, sometimes I'll do this. X is -5 cosine t, y is +5 sine t, and those curly braces. So that's it. So a lot of times with these kind of circle type equations, it's easier if you draw out the curve, like what kind of curve am I tracing out. It should be a cosine and a sine, one of the two, and you just want those periods to match up, so you're tracing that circle in kind of the same amount of time. If they give you a time, right, if they wanted one period completed in a certain amount of time, then you could do a period change on that. But if they don't specify, you can just leave it as t. So that's it for that one. In the next video, we'll do one more, I think, where we do something like this. Find a parametric equation for this type of graph, right? And this looks like it may be a really complicated graph, hard to figure out, right, what the equation might be. We're going to do the same thing as we did with the circle, right? Just basically trace out our x's and y's. You do want to pick kind of a good starting place, so we'll talk about that in the next video. So that's it for now.